All right, I'm live. All right, guys, so I'm going to show you how to make this 1 kilowatt hour lithium ion battery. Let me show you what I got here so far. This is my brick of batteries. It is 13 in series, 9 in parallel, and these are salvaged Alarm Depot cells, Samsung 2600 milliamp hour cells. I used these before, I like them. They're good. So this is a kilowatt hour with these cells, 13 by 9. And I'm going to show you how I'm going to spot weld this guy together. So you can see right there, started spot welding. So I'm going to show you a few tips and tricks. So I've done a lot of these. I run an electric bike shop here and have to make giant batteries like this pretty much all the time. All right, so what do we need? I have this here. This is a Sunco 709 spot welder, and it is the most Chinese machine that I've ever used by far. I'll give you a little, get you in here a little closer. There we go. So yeah, this is good. How I set this guy up on mine, I hit 6 and 8, and then I put it all the way up like that. I like having a lot of power on this. And let me show you a little hack that I did here to make this work. Usually this has a foot pedal that goes in here, and you push on the foot pedal and then it goes bzz, makes that noise. But this one, I've attached this is a brake lever from an electric bike, and the electric bikes have a switch on them that turn off the motor when you hit the brakes. So all I did was wire that into the switch that attaches to this and tells it when to fire. So then, when you want to weld, you just push it down and boom, spot welded just like that. Way easier, I think, than the foot pedal. Alright. So, on this one, I've already welded that first line of tin strip grid. So basically, all I have to do is just do line of tin strip. And that's what this stuff is right here. So this you can cut with scissors. It's super easy to cut. So you just line it up, set how long it needs to be. So it needs to be right there. And then chop it with your scissors. Alright. Now to hold this in place, get rid of any glue I had on there. So yeah, these never sit flat. Doesn't matter how much you try. And you can start like holding it and then welding your way down. But by the time you get to the end, it's like it doesn't line up right. So what I use are these little tiny neodymium magnets. Neodymium? I don't know. Really strong little magnets. So I take these things, line it up so it fits all the way down, and just stick them on there. Like so. Alright, so see, those hold in just like that. So yeah, now that's flat and held in place. And then I take my spot welder here, real close to you. And then I push it down, and I do two hits with it, and with 14 currents twice at full power, and that seems to make these things fit really well. And so on each cell, I do 2 spot welds, so 4 little dots. So you see there, let me see if I can get you a close up on that, and then you hold it just like this. You can see it gets red right there. Just like that. And just keep going back and forth. There you go. It's pretty easy. So I'm just going to leave this running, and you can watch me go through this battery. Start putting it together. take off your magnets as you need it. And make sure, like, these are used cells, so they have these little weld marks from whatever they were pulled off of. I heard they were pulled off of modems. And they're all tested and good. And then one good idea is I use this welding glove to hold it just like this. Now it's fine, you can touch the top, it's not going to shock you. But you can arc it, you can touch the wrong things, and it won't like shock you, it just gets super hot. Such as if you like line up these strips wrong, it'll get really hot, and I've gotten like blisters on my fingers. So yeah, you just go down the line like this. So it's a little pricey to get all this stuff. I think this machine is like $200. And yeah, everything else you need. But once you know what you're doing, it's really easy to make these things. And like, so in materials, I think for 100 cells, this is 114 cells, 13 times 9. Check that, I think it's 114. I got them on eBay from Alarm Hookup. And I think they were like, basically like $1.50 per cell. So I ordered a whole bunch of them just to have, because we do a lot of battery rebuilds and stuff here. But I have to say, if you want a little side business, making these batteries is a decent business. Just make sure you make them right. Because if you make them wrong, you're going to ruin somebody's day. In fact, probably ruin my own day making it. But I've done enough of these now. You basically know what you're doing. And after a while, you kind of understand the electricity. You know what the electrons want to do. So like touching stuff, you don't have to really worry about. Yeah, let me bring you guys in closer here so you can get a better see what I'm doing. And you can see the little red bits light up when I spot weld, which is cool. So here you can see my settings. That one's on, that one's on, that one's off, and this is all the way up. I don't know what the rest of that stuff does. You don't need it. There you go. So when you do this, you'll see these little lines. Can you see those little lines? You'll see these little lines in the tin strip grid. And you just put your weld on either side of the line. Hit it like that. There you go. That's my little magnet that I was using to hold the tin strip in place. And now you see it's all nicely flat and lined up because I use those magnets to hold everything in place. And see, now that's on there. Yeah. It's always good to check your sides. And a lot of times on the sides, I like to do an extra weld on them because that's where it's going to get ripped up. just make sure, like on your positives, see if you can see here. All right, so negatives are super easy to weld. You can weld anywhere on this. This is what the negative side looks like. This is the positive side. So these batteries just alternate back and forth. And on your positive side is harder to weld because you have less of a target. And you do not want to do this right here, where you weld between, because everything on the edge is negative, and then the middle is only the middle is positive. So you want to make sure you're not welding negative to positive, or else your battery is going to start, well, that cell will start getting hot, and then it'll start going, and that means it's shooting all of its electrolytes out. It's overpressured, and it's shorting out. So be careful not to weld your negatives. And these little circles here are insulators, and I do recommend you use these. You get them in a sheet like this, and you stick these on your positive ends of the batteries, and that really makes the likelihood of it shorting out much lower. Like I said, don't be scared of lithium-ion batteries. Did I say that? I don't think I did. But don't be scared of lithium-ion batteries. They're not scary if you know what you're doing, and they're a hell of a lot safer than a bucket of gasoline, I'll tell you that much. People are like, oh, they light on fire. It's like, yeah, gasoline lights on fire. These only light on fire if you do something stupid, like hit it with a machete. Like, maybe if I jammed it with these scissors, something would happen, but just don't throw it against the ground as hard as you can, and you'll be all right. So here's the next line. Now I got these attached. So basically the power is going like, it's going do, and going all the way through. So this is our positive side, and then our negative will come off of this side here. All right, let me raise you guys back up here. I think I've showed you just about all the tips and tricks. But for now, I'm going to just leave you guys running. You can watch me work if you want to learn how to make a battery. This is how you do it. Line up your tin strip, see how much you need. Cut it right down the middle with scissors. Take my magnets, lay it out. And I like to use 3 magnets on this, and that holds it nice and flat. And look, you're not getting shocked. You don't have to worry about that. At one point, right now, this is the first side I'm welding together, and then, so like, see, these ones aren't attached. On the other side, it will be these two attached. And right now, since there's no grid attaching any of these batteries yet, it's pretty safe to work on. You're not gonna, it's not holding that much power, but I usually do this side first and then come through on this side. And you do have to be careful because as you start attaching these, your energy buildup really gets strong. So you then is when you want to use your welding glove or any glove, anything that keeps you from getting shocked. So here we go. And when you hit the button, you can kind of see the tin kind of loosen and squish into the battery. That's a good sign. Once you do this enough, you can see, you have a good feeling of when it attaches and when it doesn't. Sometimes you'll hit it and it doesn't like attach, or it doesn't make a good weld. But as you do this for a while, you get a feel for it. And on your first battery that you're building like this, go get used cells off of eBay, because you're probably going to screw up your first battery learning how to do this. It does take, oh yeah, look, see, it just cooled off and my weld snapped right there. So just do it again. You can re-weld these to an extent. If you do it over and over, you're going to burn a hole through it. And when I do this, like, take your time. I like to leave it on there for like a second after I press the button to let it cool off, because if you just pull it right off, it's still hot, and sometimes the weld will come loose. Ooh. Yeah, see, it's tough when you're in the middle here, because it's all glued, like hot glued around the sides, this grid that holds everything together. But these middle ones sometimes will push in, so that weld just snapped. But we'll redo it. I'd say, get this thing. It is an innovation. You're welcome, YouTube battery builders. And although this would be quite a good e-bike battery, capable of pushing out 6 times 9, about 48 amps. It's not going to be, it's more for like a solar generator application, which I'll show you guys later. I just can't show it to you yet. But they sell like this. So this 1 kilowatt hour battery hooked up to this TV, or run it for like 2-3 days. I forget what this TV runs at. It's like only runs at like 20 amps or something, or 20 watts. So it will do this even with the inefficiency of the inverter. Make it last a really long time. Alright, so here, let me show you what happens sometimes on the end. Because it wasn't perfectly lined up all the way down. So now this part, I gotta push this down to make it fit. That's good. Well, there we go, another line on there. One thing I do recommend, long sleeves, because when you like lean on the battery like this, sometimes you'll hit something. It won't kill you. You'll be fine. Sometimes you'll feel a tingle or it'll get hot, but avoid, you know, avoid making circuits wherever possible. Throw an extra weld on these end ones just to make sure everything's good and tightly on there. Alright, and then once you finish your line, go through and just check it. I take my fingernail and just, if it's a loose weld, you'll feel it. Yeah, oh, that's good. Feels good. Alright, do another row. Put our magnets down. Oh, just a quick plug for my shop. If you need an electric bike, go to farbike.com. We are the biggest independent extreme electric bike dealer, and actually I have some really cool stuff coming in. Some new kits and really good batteries coming in. We're doing a whole website refresh right now, and there's going to be some really cool stuff on there. And if you have any interest in us building a battery, shoot us an email. We can build a battery for just about anything. And we do custom bikes. You can basically put a motor on anything with wheels. Or a propeller. But what you're seeing here is the future. This is basically a gas tank. And there's all sorts of applications for big giant lithium ion batteries. So these are 2600 milliamp cells. You can get like the good ones are like 3500, so instead of a kilowatt hour, this 13x9 battery would be a kilowatt and a half. But these cells are cheap, and there's no need to buy fancier cells than you need. With the caveat of get name brand. Don't buy Chinese crap. Like on eBay, you can go on there and they have like Cellfire battery cells that say they're like 9,000 milliamp hour, which is crazy. Like 3,500, I think they got some like 38s. Some new ones are, the new 21700s are going to be like 4,200 milliamp hours, which I'm very excited for, but they're not really easy to find yet. That is what the Gigafactory is going to start making, is 2170s. And I hope they make a lot of them, because the key to the electrification of the world is making these cells as cheaply and as quickly as possible. We're going to need a lot of these, because it's crazy the energy density of gasoline. We're still quite far from these batteries matching the energy density of gasoline, but in a lot of situations Batteries are better. Um, let's talk about safety on these things while you're doing this. You should have a plan in case you screw up on this. If you weld something wrong, if you bust a cell open and it starts shorting out and blowing off. I've never had one light on fire even when I screw up. They just kind of, unless you got a whole like row of them going off. If you just do one cell, usually the cell will start getting really hot and then you'll hear it go because it'll vent out of the top of the positive terminal. Um, in that situation, I do have a metal bucket over here that has sand at the bottom. You can throw it in there and then put it outside. I also have a plan to just like grab it with something and be able to throw it outside. You shouldn't have to do that, but you should have a plan. You can see that was not a good weld. That didn't stick. That's fine. You can re-weld it. You can also do this with a soldering iron and just go through and, usually I'll use a strip of wire, like this silicon wire, like this stuff. I'll strip it and then run it down, and then you can make all your connections with soldering iron. But it takes forever, and you put a ton of heat into the cells, which is not great for them. If you're going to do a lot of the machines that you can get, there's the 709A, which is the one I like. Let me show you the crappy one that you shouldn't get. That's cheaper, but it's crappy. Yeah, this is the other one. I guess it's older. The 788 Plus. Don't get this one. Get that one. It's better. Yeah, and sometimes if you're having a stubborn one, like some of these, since they have already been welded once, sometimes it won't stick right. Just hold it there and do your two slowly. All right, there's another row. Now you just, stick a fingernail under there and check it. Again, if you're doing this based on what I'm showing you and you shock yourself or burn your house down, it's on you, man. It's part of the DIY community. And like I said, let me show you the first battery cells I made. I had to rip it apart because it wasn't done right. This requires some technique. Yeah, these are salvaged from old e-bike batteries. Yeah, I keep everything like in these cases and marked them salvaged, untested. But yeah, these are the first, this is from my first tester battery I made. And you can see a bunch of the cells are screwed up, like these ones leaked. I put too much heat into them. Hadn't quite gotten the welding technique down. So when you do this, Don't assume that you're going to do it right the first time. It takes some technique and time to figure out. So buy yourself some cheap cells and do a test battery first. Run it for a little bit, try it out. Second battery, you should be able to figure it out. All right. Next row. Just make sure I checked everything here. And even if your battery, if say one of these are not attached, your battery will still work. It just won't work as well. So like if you have a cell that's not welded properly, it detaches from this tin strip. This is a 48 volt, fully charged at 54.8 volt, or 54.4. And cutoff would be 41 volts, thereabouts. If you build a bad battery and it's missing, one of the cells aren't welded, it'll start, the battery will turn off on its own. Usually at like 45 volts or something that's not 41, 42 is fine. But if you're shutting down at like 43 to 45, check your connections. You might have a bad weld. Alright, tin strip on, use your magnets to hold it in place. Make sure we're lined up here. And go down and weld. Let me squeeze you guys in here so you can... I'll move fast here to show you how fast you can actually build these things. There. You don't really have to take your hand off every time you weld. But I'm cautious, and I've been shocked enough times to be conservative. If you think it's a bad idea, it probably is. Yeah, like that weld just did stick. So when it does that, I like to leave this on there until it cools down a little bit. And that makes your welds more likely to stick. Yeah, did it that time. Move your magnets. Uh-oh. Running low on battery, let me plug her in. Since I know this is so damn interesting. Now that I've showed you guys all my secrets. There we go. Battery back in. Again, on my edges, I like to do an extra weld. There we go, another row done. So much easier and better than soldering. Do you need to individually fuse? If you don't know what that is, it's basically like running a little wire. It's the way Tesla does it. It runs a little wire to each cell. So if a cell starts like, if the cell short circuits, it'll burn the fuse, and then that cell will basically disconnect from everything else, and it won't cause a chain reaction. I'm doing that. But if you build it well, put a BMS on it, put it in a nice case, fuse both your charger and your output. I usually do like a 15 amp fuse on the charger, just in case someone plugs in something to it that isn't supposed to be plugged in. And then an output, just so if you short circuit the output wires, it doesn't just dump all the electricity all at once, which is what that black mark is right there. I was building one of these and there's a little solder ball sitting on the table and it started arcing right there, but everything was fine. Alright, so on this side, this is the second to last row. I cut these right in the middle. Some people cut them longer and fold it over the edge. I find that's not necessary. And if you're watching this, you find it useful, hit subscribe. It is helpful for us to have subscribers, mostly for the Google algorithm. If you have a lot of subscribers, Google thinks you're important. And if Google thinks you're important, then you are important. Because Google is the government of the internet. I will say, knock on 18650s, I've never horribly shot myself. I have burnt myself a few times with electricity, but I've never shocked myself really bad. Oh, also, if you have wedding rings, rings of any type, anything metal past the elbow, take it off. Wristwatches, because you can like lay it on there, and that will short it and then go through you. Might not go through you, but it will make, like, if you put your watch on there and all the energy starts dumping into your watch, it will burn you. So no metal on your person. Yeah, if you want to see something gross, I saw a YouTube video of a guy with a wedding ring, and he like touched it to his battery he was building, and it like burnt through his finger all the way to the bone. So don't do that. Don't wear rings, you know. I don't even get wedding rings. You need to show everybody your own. I wear jewelry in general. Look at me, I can afford stuff. What did that attach to? Alright, let's check our connections. I don't like the look of that one. Alright, that row's good. Now on the final row, so this will be our negative output. So we'll attach our negative wire and negative charge wire to this row right here. And the way I do this is you take your final row's tin strip, and you get rid of this. Got a bit of extra weld stuff stuck on these batteries. Having leftover weld marks isn't a huge deal, but if there's extra metal, get rid of much of it as you can. Just makes the weld stick better. Alright, so your final row, I leave one end hanging off, and then I can solder all my negative wires to that end. And you can touch it while you're spot welding, it won't shock you. Just keep an eye on what you're doing. One thing is when you're moving fast like this, you do add, it can get quite hot, so be aware of that. Yeah, like I just touched it right there while welding. It got really hot. All right, and since this is the end with the flopper, I'm going to throw one more weld on each one. Just so we don't get any loose connections. Because I have had on my e-bike where like half of this detached, I was pulling all of the energy through this side, and I was only getting like 3 miles out of my e-bike, and the battery was hitting super hot, and I was like, what's going on? Pulled it apart, turned out just a bunch of the welds broke. Didn't kill the battery, I welded it back together, and it's working fine. But I can't imagine it's good for the longevity of the battery. All right. So now you see that's hanging off the edge. I just fold it down like this. So there we go. That's the negative terminal of the battery. Now now you flip it over and you start on this side. Do the same thing down this side. This will be our positive. So that's the negative. So the positive will have the 10 strip hanging off like that, and then we'll do like that. And you want to make it so it's one down from what's on this side. So the power will go through here, and then it makes a zigzag through all of the cells until you get to the positive and sends it out that way. So yeah, that's it. Do the exact same thing on this side. I'm not going to bore you with showing that again. Let me show you a couple things that you'll need. This is the BMS. There's a 48 volt BMS. It balances. I'll do another video on showing you how to wire this up. But basically, I double side this to the side. It comes with this long wire with 13 different strands on it. And then you go through, the black one goes on the negative, which is that one we just did. And then the next one goes on the next cell, and basically you weld each one of these wires to each one of these parallel setups. And then that'll allow the BMS, that plugs in like that. And then that allows the BMS to balance the battery and keep an eye on everything. You don't need this, but I highly recommend it. You can run this battery without it. Just won't run well and won't run very long. And then when I'm done with this, I put this shrink wrap on it. So this is like a roll of shrink wrap that the battery will slide inside this, and then I use a heat gun, and that squeezes everything together. Also not terribly necessary, but it will make your battery last longer and avoid things like your welds coming undone. And then let me show you one. Let's do an unboxing here of what this battery is going to go inside. So this is a case. I got it on eBay. It ships from China. I tried quite a few cases to fit this size of battery because I built a few of them and will be building more, so keep an eye on what's going on. I can't tell you about it yet until it goes on sale. But this is I guess they call it a utility box or a craft box. It's from Sun Emol, and they make all sorts of metal boxes for different things. They say thank you, which is nice of them. And this is just an empty metal box that fits this battery almost perfectly. And I like using a metal box so if it does get hot, you're not worrying about melting plastic. And it's just 2 metal bits, so this fits nicely, almost perfectly, inside this box. So once it's wrapped, I put some foam inside this box, And at the end, you have a nice, pretty, self-contained battery box. So that's it. If you got any questions, put them down in the comments. Go to farbike.com. That's the electric bike shop we're working in right now. And subscribe to the channel, and I'll show you how to make more cool stuff like this. Thanks a lot, guys. I'll see you in the next one. Are you sure? Yes, I want to.